So what's the best programming language to learn? Whether it's your first programming language or whether it's your second or third, or maybe what's the best programming language to learn in 2020? I get this question at least a few times every day, either in the comment section or in my Instagram as a DM. My answer to that is always the same: it doesn't matter. This may sound counterintuitive to you, but hear me out. Which programming language you learn is the least important factor in your journey to becoming a software engineer or a programmer. And I'll try to illustrate that point to you today with a real example. We'll try to design our favorite to-do app today and see how far we can progress, talking about the features, technical details, how things are implemented, what sort of speed we can get, what sort of scalability we can get, and all sorts of nitty-gritty details without ever mentioning a programming language. And hopefully that will make it clear to you that when you're building an application or designing a software, the fundamentals around the concept of building software, like your data structures, algorithms, design, architecture, those things are way more important than the programming language you picked. And once you've nailed those areas down, coding it up in a language is the easiest and simplest things to do. So like I said, we will try to build a to-do app. And for that, I'm going to switch over to my iPad here. So let's say we've got a simple app that we're designing. It will have an add button to add your to-do items. And then at any given time, it's going to show you some items that you need to get done. So maybe it'll have a title, some description, maybe priority, and then due date. Let's keep it simple. And then obviously all of these are to-do items. So let's think about some features that this app would have, right? The first thing is you can add a to-do item. Okay. And then second is you can mark it as complete, right? What else would you do? And let's keep it simple so that we don't have to spend like hours designing this. Maybe add to-do item, maybe mark it as complete. And then one of the common things people do is sort it by due date. So this is sort by due date, right? And then let's say at any given time, you should be able to get your top 3 highest priority items, right? Get top K highest priority items. Okay. So once we've figured like the most basic requirements here, natural question that comes to mind is what is a to-do item, right? So now if we talk about that, we can say a to-do item obviously has a title, right? Maybe it has some description, right? It has a due date. It has a status that would be like active or complete, right? And then finally, it has some sort of a priority. That's the simple thing. Okay, we've defined the to-do. That's cool. What does it mean to mark it as complete? We need to somehow update the status, right? What does it mean to sort by due date? So we've got a due date here. So then the moment we are thinking about sorting then, so let's think about table. So we'll have something like this, which naturally makes me think that this guy over here is representing some sort of a list, right? Whether that's a table, whether that's a array of things, or whatever comes to your mind, it's a list of things, and we can sort of make it like. So what does sorting mean? Sorting means it says sort by due date. So at any given time, if I sort in an ascending or descending order, I need to somehow rearrange this list over here according to the due date, right? So that's what we are doing. So, okay, that's cool. We've got a notion of some sort of a list, and we need to rearrange that list. So if I sort it by date in ascending order, this list should rearrange to be cook dinner as number 1, then either of the buy milk or clean house can be second and third, right? Okay, and if I do it the other way, this how it is right now is fine. Okay, so that seems understandable. And then the fourth one is at any given time, we need to get a top K highest priority items. And for simplicity, let's just say top 3. So in that case, we need to somehow, again, probably sort it instead of the due date, higher priority, so that the highest priority items appear on the first, and then we pick the first 3, right? So that seems understandable. I think nobody's lost me at this point. We talked about a few things here. So first thing we talked about is a notion of list. There is some sort of a list involved, right? Which is this guy over there. There is a notion of sorting. There is a notion of add/update. And then there is a notion of some sort of a, here, let's just say sort by date and then sort by priority. Okay, so then a list is pretty obvious. Let's think about a little bit about sorting. Sorting by date, how do you sort, right? Like there is probably some sort of a algorithm to sort things, right? Maybe quick sort, maybe merge sort, maybe some other sort. So for the sorting, we can't really get away from doing a full sort because we are completely rearranging the list based on what the user picks, right? How long does it take to sort something, right? And that's what's called the time complexity. And for any sorting algorithm, it's big O of n log n, right? So that just means that if n is the number of items in the list, your total time that the app would require to sort and resort each time you do it is n times log n, right? That's how fast or slow it will be. And it doesn't matter when you have 3 items or 5 items or 7 items, but once, say, if your app scales and some really crazy productive person ends up having million items or 2 million items or 5 million items, to sort that, whether it's log n or n squared, drastically changes how long it would take, right? So keep that in mind. So for priority here, that's an interesting thing because we could do the sort again, but then your time complexity is going to be n log n, right? Like, which is fast for a sort, but if you think of priority, we are saying that our requirement is just to pick the top 3, right? So to pick the top 3, we're actually resorting the whole thing, and then we're doing a lot of unnecessary work when we just need the top 3 items. We don't need the entire list, right? So in this case, what immediately comes to my mind is a heap. And don't worry if you don't know what a heap is. A heap is a data structure, basically, that you can add things to it based on a certain number. In this case, it's our priority. And it'll automatically put the top priority items on the... So heap seems like a ideal candidate of size k, right? Because in this case, it's 3. So anytime a new item is added, we'll add that item to the heap. So the heap will always have 3 items that will be of the highest priority. So heap seems like a good idea. That way, our time complexity now becomes n log k, right? We've improved the performance of this because in this case, k is 3, right? Instead of n. And then adding an update is basically we have some sort of an idea of list. So we need to maybe add towards the end, because we are going to resort them anyways. So if there's a list of like to do 1, to do 2, the moment someone adds a new item, we'd just append it new to do, right? We'd keep appending towards the end. We don't have a requirement to remove anything. So this will be at index 0, 1, 2, 3, and then we'd know where every item is. So if by this guy over here, so we know the index. So anytime someone updates the status, we'd simply access that item and then say T3 now goes from active to complete, right? So that seems straightforward. So essentially over here, and this is like a very simplified example just for the purpose of showing you why a programming language is not that important, right? So we basically talked and had detailed discussion about essentially the data model here. So now you can make this data model in SQL if you want. You can make it in NoSQL like Mongo. You can use a wide column like Cassandra. It doesn't matter. Which database you use is probably a decision you make based on how big you want to be, how you store your data. The other one is a list. What's a list? As long as you understand that a list is probably a sequential list of, or sequential array of similar items, that's okay. Python may have a different notion of list. Java has array list. C# has list. Something else might just have like a simple array that is dynamic. That's fine. implement it however you want, as long as you understand what a list data structure is or what an array data structure is, right? The next one here that we talked about is sorting. Does it matter whether you sort in Java or Python or C# or C++? It doesn't, right? Sorting is sorting. Quicksort, we talked about quicksort. Quicksort algorithm will never change what language you're in. Sure, you'll write it slightly differently in one language over the other, but what you require to do this feature is the understanding of quicksort, not how to do quicksort in Java or Python. Those things don't change. Like converting a quicksort algorithm into a specific language takes 5 minutes. It's not a big deal. The fact that you need to understand quicksort, if you don't, may take a long while, right? Same thing with heap. What is a heap? As long as you understand heap data structure and how heap helps in this situation, you're fine. You can use the heap implementation in Python. I think it's called a priority queue in Java. C# doesn't even have a heap, so you'll have to implement your own. Even more reasons to understand how a heap works. And then you understand what are the implications of using certain data structures a certain way. What are the runtime complexities? How long would it take? Should the list grow, or should the number of items grow exponentially large, right? Like how will that impact your performance? We've talked about that. And then adding an update, we've illustrated how you'd add an update. And it doesn't matter what language it is. There may be little intricacies and differences according to each specific language, but the idea about appending to a list is the same. If you know your index, you can access it in a constant time. It's not a big deal. If you want to add to a list, you can add it in a constant time, so it doesn't take that much time. If you want to randomly search for a list, there are various algorithms. If you know if it's sorted, you can use a binary search. If it's not sorted, then you probably do a full scan, which is big O of n. All these concepts don't change regardless of the language you choose. This is a universal language that I've drawn in the screen here that you can talk to any programmer. Doesn't really matter whether they code in Python, whether they code in C++, whether they code in Lisp, it doesn't matter. They will understand what you're talking about if they understand the core fundamentals of data structures and algorithms. And that is the reason why I keep telling, whenever you ask, whenever you're eager to learn a programming language or do this, do that, at least make sure that you've got the fundamentals of computer science down. If you have that down, learning a new language, you can pick it up in 2 weeks. I'm not kidding. This may sound extraordinarily quick, but maybe the first language you learn takes time. But after that, the second language is basically the same. I hope I was clear in illustrating that point. So next time you think to yourself, hey, I'm going to learn a new language, just ask yourself again, do I know the fundamentals down? If you're lacking the fundamentals, you can learn 10 different languages. It really doesn't matter. So focus on the fundamentals. If you're in school, go with whatever language the professor or the classes are teaching you. If it's C++ or C, I see a lot of people get worried that it's like an older language. Don't worry about it. In fact, it's a great language because you learn memory management and some of the things that you don't have to learn with modern languages. So you get an even better understanding of how even memory management works for this list, right? Like, so don't worry about it. Once you finish that and once you understand the core data structures and algorithms, you can pick Python if you want. If you want to go for Android development, you can pick Java or Kotlin or whatever the latest and greatest is, right? If you are into front end, then you can pick React, JavaScript, or whatever you want. It doesn't really matter, but get the fundamentals right. That was the point of this video. Is I personally find it funny or silly to kind of obsess about what language to learn next when a lot of people haven't even understood properly the foundational knowledge in computer science. So my suggestion is to focus on that, and that's also the reason why the top tech companies never care what language you interview in, because you can learn that, as long as your fundamentals are sound. And so yeah, hope you liked this video. It was a little bit different. Rather than me just talking, I wanted to show you with a real example and how far you can discuss the details of an app without even talking about a programming language. And in fact, that's how it should always be. That's that. Hope you liked the video. If you did, please like, comment, share. If it's a generic comment, put it in the comment section. I'll do my best to respond to every single comment. If it's a specific comment that applies to you and you want to message me directly, reach me out on Instagram. I also try to respond to every DM there, although it may take time because I'm short in time. But that's it. Cool. See you later. Bye-bye.